All right, so I'm going to go ahead and start 3.5, sinusoidal functions. Now, I'm pretty sure I'm saying that wrong, but essentially any function that is an additive or multiplicative transformation of f of theta equals sine of theta is called the sinusoidal function, right? So looking here, I'm going to quickly just draw a cosine and a sine graph. We kind of already did that in the last video. So if this is 1, and then at pi over 2 is 0, we're at -1, 0, 1, just so you can kind of get the idea of what the cosine is looking like. And then the sine function is going to look something like this. Okay, so now if you notice, I don't know if this will let me do this, but I can perfectly typically you can perfectly match up your sine and cosine graphs. Like I said in the 3.4 video, the sine and cosine graphs are actually the same. It's just one is moved in a slightly different position. So that's the only difference really that's going on. Try and get this back in the right place. Okay. So what that tells me is that this f of theta equals cosine of theta is an even function. And because it has reflective symmetry over the y-axis. So if I were to basically fold my cosine function over the y, I would get a matching function on the other side. Now for sine of theta, well, sine of theta is actually an odd function because it has rotational symmetry about the origin. So basically saying if I took my sine function and I rotated around my origin, which 0, 0, I would be able to line up my graph perfectly. So now you can see cosine of theta is a transformation of sine of theta. If you look at the graphs, we can shift sine of theta by pi over 2 to the left and it will match up. So it's kind of what I was just showing you before. If I move them over, I can get them to match up. So you have your standard equations for cosine and sine. So remember that A represents any kind of stretch or shrink in the function. Now, it does have a special kind of rule in this. So sine functions and all the trig functions basically have their own vocabulary. It's not just like what we're used to, slope and horizontal shift and all that stuff. It has its own terms. So here are the terms. You have the amplitude, which to get the amplitude, you need to do the absolute value of A. So whatever this is in your functions, you have to do the absolute value. And that is half the difference between the maximum and minimum values. So that's how you figure out the amplitude. Midline is a horizontal line halfway between the maximum and minimum values. It is determined by finding the average of the maximum and minimum values, and the concavity of the sinusoidal will change when it crosses the midline. So basically the midline is, yeah, it's so much words to basically just say this line here is your midline, right? Essentially, if you think back on the parabolas and the other functions that we've done, we had a point of a turning point or point of inflection. I think it was what it was called. Is essentially it was that halfway point between a minimum and a maximum on my function. So basically a midline is if you took that graph, that point, and you just created a horizontal line from it. So in this case, as you can see, my purple line is actually going to line up with where the default midline is, which is at y equals 0. So it will change if I have a shift in my graph, right? So the midline default, though, is y equals 0. Then I have the period, which is the cycle, which we've kind of talked about before, and that's 2 pi, and it's the reciprocal of frequency, the change in theta values required for the function to complete one full cycle. So like what we had talked about before in like 3.1, I think it was, where basically you had a whole length of a segment of the function, and that was one complete cycle. So in this case, they call it a period as well. So then the last thing that we have is called the frequency, which is 1 over 2 pi, right? They kind of gave it away in the period and says the reciprocal of the frequency. So if the frequency is 2 pi, the reciprocal is 1 over 2 pi. So the number of cycles the graph completes per 1 radian. For this functions, the frequency is approximately 0.159 cycles per radian. So it's basically trying to tell you how many periods happen in a set range. So if you were to have a radius of 5, right, you'd want to see how many times your period appears in that function. So now we have more of the graphs, which these examples you are going to have to do on your own. So make sure you pause the video and try them out. I will have the answers for you on Monday, and that is the end of 3.5. So make sure that you practice these questions so that way come Monday we can go over the answers.